Good afternoon, this is Mr. Schweitzer, and this is on one of our first videos here on addition of vectors. Alright, so when we're adding vectors, we want to be able to take many vectors and add them together. Pretty standard, something we want to do. This is a two-dimensional vector, so whether it's a person walking, driving, wind, blowing a ship around or ship traveling, any vector can be added in this way. Alright, so first things first, we know we could solve this thing using a graphing method. Not very accurate way of doing it unless you give a nice set of graph paper, but we always want to have some idea what we're doing here. So Mary walks to the east. Let's just say she goes 2 miles this way to the east, and then she walks 1 mile north, and then she walks 0.5 miles Alright, so we got we traveled 1 mile north. Alright, so now we're going to go 0.5 miles at an angle of 20 degrees north of east, so a shorter distance, and I'm just going to estimate that this angle right here is about 20 degrees. And then we go 2 miles north of west, so a little longer distance with a similar angle. Okay, again, I don't know how long that is. Again, it's just a general idea. And again, this is the same angle here as it is right here. Okay, so the next we'd say, where is this guy located? What is this new resultant vector going to be? Alright, so let's start doing this thing mathematically. So I have all my x components and I have all my y components, and I'm going to start adding them up. The first guy goes 2 miles east. Now again, east is going to be a positive, west will be a negative, north will be a positive, and south will be negative. So first off, we got 20 miles east. That's a 2 miles east, positive 2, that's nothing in the y direction. 1 mile north and nothing, this is 1 mile north, nothing in the x direction. Now for the other guy, I got 0.5 miles north of east, so just drawing this out here a little bit, we're going, in this case, we got the angle, which is going to be 20 degrees. This is 0.5 miles and it's north of east, so this is my y component and this is my x component. I will be getting some of each. The math on this is going to be the sine of the 20 degrees times 0.5 will give me my component, and then the cosine of 20 degrees times 0.5 will give me the x component. So punch that out. Is 0.171, and the cosine of 20 times 0.5 equals 0.469. Not real long because it's a small distance, but let's add in here 0.171 and 0.469. Alright, and then one more, we have a little bit different distance here. Now I'm going to show one way to calculate this, and there are others here, but this is one way. We're going 22 miles north of east. Alright, so quadrant wise, this is what we're doing. And this angle is 20 degrees. This is 2 miles. This would represent my y component, and this would represent my x component. Now I'm using 20 here. This would make this angle right here be 70 degrees right here, and this component here is 90 degrees. So I could do this with 20 degrees like this, or I could use the angle, same math on this guy, 160 degrees. That would give me the same exact measurements that I would like. So if I use the 160, then the cosine of the 160 times the magnitude here, which was 2, will always give me my x component. So if you start from the baseline of 0, then the cosine always gives you x, and the sine always gives you y. Again, that's a little mathematical trick if you would like to try that. So the cosine of 160 times 2 equals, now this is giving me a negative 1.87, and then we have the sine of 160 times 2 equals a positive 0.68. Now again, what does that mean? It means my x is a negative 1.87 and this is a positive 0.68. So the nice thing about using the 160 is it gives me my direction. If I did this one, I would get 1.87 if I use the 20, and I need to know at that point that it is going to the left, which is negative. And it would give me a 0.68, but I have to know I'm going north, so it would be a positive. So using that, all the angles from the start is a decent little shortcut. And then I'll add these in here, and x would be a negative 1.87, and this is a positive 0.68. All right, and you add up these components. All right, and the y component will be 1.85 up, and this is going to be a positive 0.599. Alright, so let's rebuild our newest vector, and we want to take this thing and go 0.59 up. So this would be 0.59 on the x coordinate, and I would just sort of draw this like that. And then I want this guy to be going up 1.85, 0.59, and this is my new vector. Now in my sketch I had it coming across, I guess, but really it was more right here. So sometimes it's difficult to know if you're just guessing or estimating. I want to know this angle or this angle and relative distance. So at this point I would take this is a right triangle right here, so I use Pythagorean theorem. 1.85 squared plus 0.59 squared equals my hypotenuse squared, the resultant squared, and the math on that will be 1.85 squared plus 0.59 squared equals, now square root that value, and I get r equals 1.94. So now that's this value right here for the length of this guy right here. Now I want to find that angle. Now generally we give the shorter of the two angles, but I'm just going to go with my inside one. It doesn't really matter. You can flip it to the other side very easily. This is 1.85. This is 0.59. I'm going to use the and this is going to be 1.94. So any of the trig functions you could use. Let's go with the sine function. Sine of the angle equals the opposite, 1.85 over 1.94, and 1.85 divided by that 1.92 is 0.952, and then of course I want inverse sine to expose the actual angle. So the second sine of that answer is equal to 72 degrees. So this angle right here is 72 degrees, and the other side would be, this side would be 17.6 degrees. There's some rounding there that I miss. 17.3, so that would be overall 17.6. So this thing has a magnitude of 1.94 units of length, and it gave it as miles. Okay, and then I want to give the direction as either being 17.6 degrees, and that would be east of the north point, or it would be 72.3 degrees north of the east point. And those are my two answers. Thank you very much.